Hi and welcome to MSc. In this video we're going to be looking at geometric sequences. Geometric sequences have a common ratio. So unlike arithmetic sequences that have a common difference, go up by the same amount, this goes up by the same multiplier. I did a quick video on arithmetic sequences, so if you're interested in checking that video out, you can check that one out as well. This common ratio can appear as a constant multiplier. So again, when I'm faced with a sequence and I'm trying to identify it, I like to look and see how much each one's going up by. And we might not always know we're looking for a multiplier. I could say, well, this one goes up by 4, then this one goes up by 12, and so on. And that can sometimes help you build a pattern. But in this case, we notice that this can go up by a multiple of 3, and this goes up again by a multiple of 3, and a multiple of 3. So this 3 will be known as our R value. This is our ratio value here. And as we see in the explicit formula, we have again this general term, UN, which can be defined by the term number itself, 1, 2, 3, 4, 5, right, n equals. And I do find listing that out is helpful if you get one that's not arithmetic or geometric and you're kind of stuck trying to figure out the pattern that's there. This other one though, we can see, well, look, here it looks like I'm dividing by 2. And it's interesting how oftentimes we look at this and we see the division before we see the multiplication that's actually happening. So of course, instead of saying divided by 2, we can say multiplying by 1/2. And the trick here is that this has to be the R value here. So that's the R value, not the divided by 2, although it's the same thing. Mathematically, we have to put the half into our explicit formula. Again, you might have seen something a little different in this explicit formula. You might have seen it as Tn for the general term, and then an A value for your first term in the sequence, and then R to the n minus 1. Okay, so either one of those will be perfectly fine to use, and everybody will understand what you're using. As long as you're using one of those, they'll be both clearly understood. Again, this first formula here is typically what's given in like an IB formula booklet, for example. So let's go through and quickly create the explicit formulas for both of these examples. So this first one on the left side here, we know that the UN, the general term here for each one, is going to be the first term, my U1 or my A, which is 2, and I'm going to multiply by R to the n. So R is 3 in this case because it's going up by multiples of 3, and then it's going to be n minus 1. And there's no simplification here. I can't multiply the 2 and the 3 together because they're not the same base, and I have an exponent here. It would be different if I was able to reduce this or break this up into different pieces, or if they were the same base, for example. That's not the case here, so I just have to leave it as is. Over here, I have this example where I have the R value is 1/2. So I start off with a value of 300, and we're going to multiply by 1/2 to the n minus 1. And again, I can't simplify this in any way at this stage, so this is typically how we leave it. Now, I am able to use these formulas then to solve for a future number term in here that's not listed out. Again, my terms are 1, 2, 3, 4, 5. But I could solve for, say, what is my 9th term? So I could say U9 is equal to 300 times 1/2 to the 9 minus 1, which is 300 times 1/2 to the power of 8. This would be the same as 300 times, and this 1/2 to the power of 8, well, 1 to the 8 is just 1, and 2 to the 8 is 256. This fraction then equals 300 over 256, which you can then work on reducing, because clearly at least 2 can go into it because they're both even numbers. And this is where if you have a natural display calculator, it'll actually simplify the fraction for you. And you can find out that in simplest terms, this is 75 over 64. That's an exact value. As an approximate value to 3 sig figs, this would be 1.17. That's rounded to 3 sig figs. So look what the question's asking. Typically, we want to leave it as an exact value, but you'll notice that we do have decimals presented in the question, so it might be appropriate to have decimals in the answer. Look at what your teachers suggested is the rule for you. Look at what the question's asking and go from there. Certainly, if you didn't have a calculator, you'd be leaving it in reduced fraction form. So this is geometric sequences. And again, you can have more complex problems where they're word problems or where you don't know all the information and have to do a system of equations perhaps. But this is just intended to be a quick intro into geometric sequences and their explicit formula. I hope it's been helpful. If it has, consider liking the video and subscribing to my station. And as always, thank you very much for listening and watching.